Guys, good morning, guys, and thanks for joining the session for this advanced Linux and shell scripting class. So we just started from today, right? And this is very important for us, all of us, to learn Linux. Okay, so what is the purpose of learning the Linux actually? So we know that basically in our day-to-day activity work, that's on DevOps, right? Like we'll be always interacting with the Linux servers or Linux machines, or in some industries they are still using some old legacy servers, right? Like for example Solaris or IBM AX servers, right? So uh, all those are clones of Unix operating system, but still, like, being a DevOps engineer or professional, right? We should always learn Linux actually, because as a day-to-day activity we always interact with the Linux servers, because all those applications, softwares, everything they have integrated with the Linux operating system. So Linux is widely spread across in every part of software, right? Like starting from your like starting from your banking software, you know, till today, like whatever we have embedded systems or embedded machines, right? Everywhere Linux is installed. Means Linux is working. Even if you see, like if I talk about something like you have an Android mobile, right? Even Android mobile is nothing but it's a Linux itself. It's a Linux kernel itself, or it's a Linux OS. Okay, so even like Linux is even used across many places. Even Linux is used. Suppose you have a washing machine, okay, or you have some electronic appliances. Even there also Linux is used actually, but it's a customized Linux or customized OS they use. So now, coming back to our requirement, like why we are learning Linux. So basically, learning Linux is something like you have to know about little bit information about. See, in the day-to-day activity of the data DevOps, right? What we do, we hardly interact with Linux, right? What are the how the DevOps engineer, particularly I'm talking about DevOps itself here, because we are covering all. We are into DevOps professional, right? We are working as a DevOps engineer, right? So we need to know like how exactly Linux we use actually. You know that the DevOps engineer, he uses the Linux as like he uses the Linux as something like he logs into the Linux server and executes certain commands. Correct. This is what 90% of the time, like, people always use Linux, right? Because he has been told that, okay, so some tool or some application is configured into that particular server, so you will be given some kind of a credential or the IP address with credentials. You log in with that credential and you log into that server, right? And you would be provided, or you would be told to execute some commands, or else either you know the commands or you refer to some document to see that commands and execute it. But that's what you do, Max, right? Or else you have been told to go to that particular path and execute that script or certain job, right? So that is what I would see that most of the maximum DevOps engineer would do, right? And even they are even restricted to do up to there only, right? So that's the reason what we I have seen that most of the DevOps engineer in today's world, right? Yes, they are very good in the tools and all. If you ask them about internals of Linux, or ask more in detail of Linux, yes, they would not be able to no tell you the answer, or they'll not be able to give you any kind of an answer. Why? Because, right, they have a very limited knowledge on Linux actually. Okay, so again, the question comes for all of us, is that is Linux is required to be learnt in a very in-depth manner, or you need to learn in a very intermediate manner? What is the level of no Linux understanding which each and every DevOps engineer should have? So the answer to the question is that actually, to come up with the DevOps, or to understand with the DevOps, before the DevOps, like before the DevOps. See, this terminology DevOps engineer, right? You have never used before some 6 years. So there was no word by name DevOps before 6 years, as per my understanding or as per my knowledge, 6 or 7 years. Before that, what were people used to call? See, people used to call like application support engineer, or else you might have heard about production support engineer, right? Production support engineer, or else max like we used to learn about tier 2 or tier 3, tier 3, support engineers, right? Like that, we have been, we have been hearing actually, right? No, and also like sometimes you used to even call them as a system admin, like system admin, managing of the entire system or the softwares or the configurations and everything, correct? So these were the different terminologies were used across the industry before the DevOps came into the picture, right? Now, what has happened slowly? What happened? Like we bought in a culture where what happened, right? The support engineer or the system admin or the tier two, they can nicely interact with the developers to achieve certain tasks. So there was a culture which was developed actually. Culture means there was some process which was which was formed where a system admin or a support engineer can interact or will interact with the developers to make sure that actually the systems are properly working in the test environment. Right. See, basically, as a DevOps engineer or as a application support engineer, we can either monitor or we can either support the test environment or production environment, right? So you might have a different environment for different people for supporting different environment, or else a DevOps engineer might support both UAT, test environment as well as a production. So to make it very smooth operation, right? So to make sure that there should not be any issues with these environments, DevOps engineer basically, right, or a system admin, he try to interact with the developer to lot to understand to fix any kind of issues into this environment. So that's the reason there was one, there was one process which was formed, a nice process was formed, where the DevOps, the not DevOps, like the support engineer, he interacts with the developer in a very comfortable way, and there should not be any kind of a gaps between them. It means that there should not be any understanding gap, or there should not be any kind of a huge gap between what the developer is doing and what DevOps does the configuration system. So there has to be a match between these two people. So that's the reason what happened. This DevOps word came into the picture last 6 to 7 years back. Otherwise, if you see, if you strictly ask us actually what exact DevOps is a system admin only, guys, or he is like a support engineer only, right? So because DevOps engineer, he doesn't, work on any kind of a coding. Yeah, of course, he should have some knowledge on coding, okay, but still he is not a true developer. He doesn't develop any application from the scratch, right? He only supports for that application. Whatever the infrastructure is required for us to support for that application, those infrastructure we manage it, right? Like for example, server management or infrastructure management, provisioning, right? Setting the whole software stack, what is required to execute or to run that your application, that whole infrastructures, the DevOps engineer sets up. So that's what. But still, what happened, right? The DevOps terminologies keep getting changed over a period of time. Slowly, like for example, DevOps also nowadays you can see that they are also getting into some kind of a coding, right? Earlier they were never used to code, and now they started coding on shell scripting, Python, many other languages. They started coding, and they are able to understand. They are able to do a lot of automation tasks using this scripting and all, right? So that's the reason now the definitions are little bit changing, and DevOps are they are used in many different domains. Like you might have heard about security, right? So in security also a lot of DevOps engineers are getting into it. So they are called as a DevOps SecOps, SRE, Site Reliable Engineer, right? So these are the terminologies you might be seeing actually. DevSecOps, right? And also you could see even like for example like ML, machine learning ops. So you need a people who has a knowledge on DevOps things, everything, as well as you should have a knowledge on machine learning or a data science. So there he will play a major role, right? And also where else, so everywhere what happened, right, the DevOps are getting into it, and the terminology or the working level also is keep getting changed actually, right? Now back to like if I ask you, like if I say that in back to some 15 years back, like in 2000 or 2005, or in those time, right, like the people used to get called as a system admin. Even what happened, right, I have interacted few of the system admin very long back, like 10, 15 years back. So what they used to do, right? They were trying to monitor some kind of a service on a day-to-day activity. If you go to the industries, right, where there are a lot of system admins are there, so their major task was to just install the packages, configure the package, Okay, that is what the little role they were doing actually. They were playing, installing the package, configuring, as well as monitoring the systems. So they were doing some of the little, work which which they can do, as well as like if you ask the system admin during that time, right? I have a requirement to automate certain tasks actually. Whether you can automate that certain task. So system admin is to say that no, I'm not a developer or I'm not a script writer. I will not be able to write the scripts and all. You ask the script writing everything to the developer itself. So during that time, I'm saying that the developer itself used to write the scripts, right? So whatever the automation task is to come, right? The developer only is to do that actually. But now what happened? As slowly keep as keep in the technology is growing, even there was a requirement for even the admin or support engineers also to learn all these automation tools or scripting level or programming level, so that they can comfortably do, and they can avoid asking any kind of stuff to the developers. So developers are no longer getting into writing any scripts or automating any kind of a task. Okay, so this is all about like what exactly the how the DevOps came into the picture, and what exactly DevOps has to work or understand. So DevOps nowadays, right, he is involved in every task actually, right? From the automation to the setup to the setting of the infrastructure automation, and also the monitoring the systems, right? Monitoring the health of the applications. There are many things are there where the DevOps engineers works, right? So now coming back to the Linux actually. Now why we need a Linux actually? So Linux, as you know, that Linux, most of the infrastructure today, what we saw, right? 90 to 95% of the infrastructure. It means that 90%, 90 to 95% of your infrastructure, everything is there in some kind of a Unix or the Linux operating system, right? We'll get into this terminology later. What is Unix and Linux? Some people might have a not confusion. They have some doubt. What is Unix or Linux? Both are same, or is it some completely different? We'll discuss about that later. So now we know that most of the infrastructures, like in every industry, right, they are having on Linux itself, or on Unix actually. But if you ask me, Unix is getting absolute. So most of the now it is everything everywhere. It's Linux itself. So basically, you have to only concentrate on only on Linux. Okay. So when so much infrastructure, everything, it means that your server setup and your application deployment, your application, everything is running on Linux itself actually nowadays. So 90 to 95%, it means that wherever you go, in whichever industry you go, you have to interact with the Linux machine. There's no choice actually, right? And you could see that something around 10%, if I'm not on 10% of the infrastructure is there in Windows operating system. Is in Windows operating system, right? Even in our companies also, if even in our company, in my company where I'm working, right? So if you ask me, like there are lots of applications are there actually in our company. We manage a lot of applications, but 95% of the application actually it resides, or it is executing, or it is running in Linux operating system. Only 10% or 5% of the application is running in a Windows. That too, we need some kind of a services, like for example TIPCO service or plus service, right? We need, and also a few of the applications which we need for the GUI part, right? So that's the reason we are deploying, or we are running those applications in those machines. Or else 95%, as I said, it is working on Linux. So I have to know Linux actually, being a DevOps engineer. Okay. Now the question comes to what level we need to understand. What is the level of? Is there any level of understanding Linux? So the question comes, many of the people, what they said that, okay, if you want to know about Linux operating system, So what they would say that, okay, you should know commands, you should know like how to do some configurations. It means that suppose if you are given a file actually, and if they've been told that go to that particular file, edit some of the config, means that change some of the values and parameters, or go to some configuration file, change this particular line. They would say, so you need to go to the configuration file, change it, save it, and do apply the config. After the changes, apply the configuration. And if there is any services that related to that, you will say that reload or restart the service. You say. So if you see, most of the DevOps engineer, he would be doing this the same thing in a day-to-day activity. That's all. He might be knowing some commands, right? And he would be knowing like how exactly the application works, in which particular path the application resides, where the logs are getting generated. Okay, and if the developer or somebody asks you to do some config changes or something, you go and you do it, and finally you try to restart the service or reload the service. So this is what day to day any DevOps engineer works, right? Now, if you ask him in detail about Linux operating system, what is Linux, man? What is a Linux operating system? How things works inside Linux operating system? He might not able to answer you. He will not be able, he will not he doesn't know all those things, right? So now the question comes, right? Like, okay, fine. He doesn't know. Is it really required for him to learn so many things, or is that knowledge is required that where he need to have a very in-depth knowledge on Linux? So if you ask me the question, what I would suggest or what I would say that yes, he should know it. Yes, yes. Understanding Linux to a certain extent, understanding the Linux operating system to a certain extent is required for the DevOps. So again, you might ask like, what is a percentage? If I need to know some 50% or 70 or 100%, what is a percentage actually? See, there is nothing like a percentage here because Linux is so vast and it is like a big ocean. If you start working or you start learning Linux, it's a never ending actually. So I cannot say that actually like you need to know 50% or because you cannot gauge the percentage when it comes to understanding Linux, right? It's not only with Linux, it is any tool actually. See, if you work on Jenkins, you work on Docker, Kubernetes, you work on Terraform. Do you think that there is a end for any kind of stuff to say that okay, this is the end part of the tool? Beyond that, there's nothing. No, right? Because like every day the tool is growing. It means that every day some kind of a new feature is getting added. So the tool is growing like anything. So you cannot gauge with any percentage, right? So that's the reason I cannot say here that like you have to know 50% or 80%. It is not possible to tell you. But what happened, right? There is some basic require. There is some basic, like for example, there is a basic requirement is there. That basic requirement, there are certain things are there which you should know perfectly. So once you learn that perfectly, and once you work on that, whatever the knowledge which you have gained, right, with that, once you apply that knowledge at your workplace and you work it and you understand it, then I would say that okay, now you are comfortable with Linux operating system. That what are those contents and all we will discuss later on. But I'm saying that there is certain things are there where you need to know all those things, right? Take for example, how means what are things you should know? For example, simple. Like for example, you should understand what is an environment of Linux. Environment of Linux means basically you should have some knowledge on what is user space and kernel space. Guys, we'll come to these things and all later. What exactly all these things are? Just I'm telling you. You should know about something on what is a shell. Okay, what is a different, stack of your Linux operating system. Okay, what is a shell? What is a different stack of Linux operating system? You should know something about your like you should have a knowledge on commands, but not only with commands, you should also understand like why exactly these commands are, why these commands are, and how this command will get executed. So you should have some basic knowledge on it. It means that you should only have very very basic knowledge. Okay, I have some command means how this command will get executed. Okay, okay, internally how exactly it get executed. You need not to go in detail in there, but still some in a very high level you should understand it. Actually, you should have a knowledge. And also, of course, after that, what happened, right? When you're working on shell, yes, you need to know about the shell scripting also. Yes, shell scripting very well. So understanding shell itself will take some time, guys. So after that, you need to learn about what is the shell. So you need to learn about the shell scripting also. That is also very important. And of course, after that, you need to understand uh, many more things about what are the different servers we have. Like servers, like for example, you have some web servers, right? Web server means you have an Apache or Nginx server. Like you have a DNS server, you have a DHCP server, right? You have a DHCP server, DNS server, Samba server, Squid server, or sometimes if there's a requirement for you to learn about the mail server, yes, you have to learn the mail servers, right? Apart from that, how to configure, how to configure SSH, okay, FTP, FTP. Telnet is not required, okay, but still we'll add Telnet. So there are many kind of services are there which you need to learn, and also you need to learn about the networking, particularly Linux networking, I can say. So these are some of the basic things, and of course you need to learn about the LVM, or you can say that partitions, Linux partitions. There are many things out there, guys, to learn. So if you learn some of this, all these things, whatever I have described, there are many more things are there. I just described few. If you learn all these simple few things actually, then you can comfortably say that yes, I know Linux to some extent. That's what it is. But there are many more things beyond that. But I'm just describing these are the few things which you should know. If you ask any DevOps engineer, he should know about the networking part very well. He should know about different kind of servers and all. Okay, even though he might not see, even though as a DevOps engineer you might not be using the DNS, but still you should know how internet DNS works, or very basic level of learn understanding about DNS, DHCP server, like that NIS server, NFS server is also there, right? NFS server. So you should have some basic knowledge. I'm not expecting that you should have a expertise in each and every services, right? These are the different, server level applications. I'm not expecting that you know, but somebody if you ask what is a Samba server, you should be able to tell something. Okay, this is what the Samba server. So that's what it is. Yes, scripting part we will be learning because to automate the task, a lot of stuff you need to know scripting, right? Commands, yes, commands are the heart of Linux, right? Like within that, without command you cannot survive in Linux. You have to work on commands, you have to execute it actually, and you need to learn about some kind of an environment of Linux where you will understand how exactly Linux comes into picture. With that, many people would also even know very a lot of things about the installation also, right? What are the different types of Linux installation? What we do in Linux? Suppose I want to install Linux, how you can install Linux and all. So many people have some knowledge on installations, different part of the Linux. Lot of people will have a knowledge on your virtualization. Okay, so they would be using something like Oracle VirtualBox or some kind of a VMware to install Linux. And where if you install Linux on this VirtualBox or a VMware or any kind of a virtualized software, right? So your Linux will act like a virtual Linux machine, correct? So some people are mastering this actually. So these are all the technologies. As a DevOps engineer, guys, we should know it actually. It's very important. If we know all these things, we can actually comfortably work on the DevOps level, right? So now, so now why we have started this Linux classes actually basically. See Linux because all these days we are learning some kind of a tools, right? Yes, it is good. We have been interacting with the Linux because in the Linux operating system we are installing a tool like we're installing Ansible or we're installing Kubernetes, we're installing Docker and all, right? But all these days we are working on the DevOps tools itself. Those are all the tools. But what is the need of learning Linux actually? See, because if you have very good knowledge, so if you have a very good knowledge on Linux, you can actually you can better understand the behavior of the DevOps tool. Like for example, if you have a very good knowledge on Linux, suppose you are installing Jenkins, you can clearly understand how exactly Jenkins is working or how exactly Jenkins is reacting whenever in a job is works. It means that through the Linux perspective, you can understand in a very well manner like how exactly Jenkins comes to. Why? Because right, for example, when the Jenkins works, actually, when the Jenkins working, when Jenkins is working, running, the service is running, and you know that actually when you are working on any job creation, I'm just saying because we have not yet did anything on Jenkins, but some of you have some knowledge on Jenkins. So on that way, I'm just telling you that when you're working on Jenkins, most of the jobs requires some kind of a environment variable. Correct, guys? You might have come across some of you environment variables. Now, if you understand, if you don't know what exactly environment variable, yeah, there is some step is there. Okay, you will go to the document, you will just copy paste it, and you will say that okay, you're presetting some environment variable. But if you're not understanding what exactly the environment variable is, how Jenkins that particular job is effectively using that environment variable, you will not be able to appreciate how the Jenkins works, right? So you are just following some kind of a rudimentary document where they have been told, okay, if you run this job, make sure that this environment variable set in your operating system or in Linux. You'll go on and copy paste that command and execute it, right? That's what max you do. But what happened, right? You would not be able to appreciate it. So like that, this is one example. There are many things out there where each and every DevOps tool, right, it nicely interact with the Linux operating system. So it is always better that you should learn Linux very well, right? So that's the reason you have to learn Linux. Okay, Linux is very important. Now, coming back to us, sir, like what we are going to learn. So we are going to learn step by step, sir. Many things, from very basic scratch level to some advanced topics we will be covering in all this entire complete session on Linux. That's what I have planned to take it up. So we will see. Let's see how things goes when we start moving to learn more and more on Linux, right? So we'll see how in different like higher concepts we can learn everything. We can just see later. Okay. Now, now, okay. Now, so let's start our journey, guys, on Linux. So it is very important that we should start from a very basic thing on Linux operating system. Correct. Now, so before getting into the Linux operating system, guys, so I want to just ask you, some of you, so what is an operating system? This is very basic question where everybody asks, what is the operating system? Some of us might have learned in our in our engineering days, right? Or in our graduation days, we might have learned about what is an operating system. Now, so can anyone give me at least some kind of a textbook definition, guys? If you have any knowledge, anything, whatever comes to your mind. What is an operating system? See, we say Windows. This is a Windows machine, right? This is Windows machine. We say this Windows is it's an operating system. We say, or it's an OS. We say similar, right? Similarly, wherever you see Linux operating system, right? You say it's a Linux operating system, right? Or else you see somewhere in some MacBook, you say it's a Mac OS. We say or Mac operating system. Correct. So, what is an operating system? Just give me a textbook definition. Okay, it's a medium build pattern. Any other thing, something coming to whatever the answer you give, it is good only.
Our computer and hardware.
It is a computer and the hardware, user and the hardware. Okay, fine,
Yeah.
good. So yeah, some different answers are coming. All are correct only. There's nothing like wrong actually. Everyone are giving some kind of an answer. So now Linux, sorry, operating system. See how I define an operating system. Operating system is nothing but it is a system software or it is a set of programs that control and coordinate operating system is nothing but it's a system software, or it's a set of programs or set of modules that control and coordinate the hardware resources for the different application programs. Now, what it means? See, this is something like a hardware, guys. So there's something like a hardware. Now, if you ask me hardware, what is hardware means? Hardware is something like hardware. So hardware is something like, see, you have a keyboard, you have a RAM, right? You have a mouse, you have a screen, or you have a terminal, right? You have a hard disk, and there are, like if you open the motherboard, if you open the computer, and if you see, there are many chips are there inside, right? A lot of chips are there, electronic chips are there. These all act like a hardware itself. These are all a hardware only, correct? Now, these are the hardware. Fine, these are hardwares are there. Suppose I want to utilize the resources of this hardware actually. So I need to utilize the resources of the hardware. It means that basically you need to have some kind of an application, guys, or some kind of a program. You need to have some kind of a application, or else you can say some kind of a program should be there, where that program can actually interact with this hardware like this. But application or the program, it cannot directly interact with hardware, right? How it can interact with hardware, or how it can communicate with the hardware? It cannot communicate with the hardware directly like that. It's not possible for any application directly to interact with hardware. So that's the reason what happened. There is a small piece of code is coming here. This small piece of code is nothing but it is an operating system. So whenever this application it want to interact with the hardware, or whenever any program want to interact with the hardware, it can interact with the hardware with the help of an operating system like this. So operating system, it it is nothing but it's a set of models, or it is nothing but it's a system software that controls and coordinate the hardware resources for the different application programs. Each and every application program. It's not only one, guys. There are many application programs which are running in your system, right? Like this. So each and every application programs, it requires some kind of a hardware resources to fulfill its task. So this application, for example, now if you see here, I want to launch my google.com, or I want to open the google.com. What you will do, you will go here, or you know that, oh, I need to go into the browser client. So you do a double click on here, not to do Google Chrome. Correct, guys? We'll just double click on it. So what happened? A browser is getting open, and finally, okay, this is open, the default is open, or it is default open the Google page. But I will say that I'll say www.google.com, and if I say enter, see, you are launching a Google page, right? Now, what as a user I'm doing? Basically, what happened that I'm invoking an application, or you are running an application. So here, if you're running an application, it means that you are running a program. So here, if you, in a very common way, if I want to start, see, you are actually running a browser, correct? And that too, it's a Chrome browser. That is also a kind of an application only. It means that because you want to achieve certain task. What is the task? I want to open a Google page. So what for doing that, actually you cannot directly do that, right? You need to have some kind of a web browser, or you need to have kind of a web client. So that web client is nothing but you can achieve through with the help of a browser only. So do a double click on it. See, when you do a double click on it, basically you are actually executing, or you're running an application, right? So now, whenever your application has to run, or it has to execute, it cannot simply run like that, or it cannot execute like that. So what it has to do that, whenever you are double clicking on any application, what happens? You are invoking, you want running that application. How this application will get executed, or how this application will start running? It will start running with the help of an operating system. Operating system will make sure that your application will run actually. So operating system will make sure that application will start running, or it start executing. Without operating system, you cannot run any application, guys. Yes, some might say, but Rajesh, there are many there are many stuffs where without operating system also they can run some application. Like what is that? Yeah, there are certain things are there. We will discuss later on what is those things. But yes, in in some places, like you have, if you don't have a complete full-fledged operating system, or you don't have an operating system, still you can run that application. That I'll talk later. Okay, but if you take right 95% places where you need an operating system, you have a hardware, you have an operating system, and you have a different application where the application has to interact with the operating system itself to run. Without operating system, the application cannot run. So now there are so many applications are there which are running. Each and every application, it requires some hardware resources to complete its task. So each and every application, it requires some kind of a hardware resources to complete its task. What are those hardware resources? Like you could say that, okay, this application, it requires some memory, correct? It requires some memory to get executed. So it requires some memory. Okay, it requires some memory. It requires some CPU cycles or CPU time slice, right? So like that, there are many hardware resources are there which each and every application requires. So what this operating system does, operating system, it will going to suffice the need. Okay, you need this much of memory, this much CPU cycle. Okay, let me assign this resource to you. So what the operating system does, operating system interacts with the hardware, or it communicates with the hardware. It understands the requirement of the application. It communicates with the hardware. It provides that resources for that application so that, okay, take these resources, right? And operating system will create an environment so that this application will start running or it start executing. So creation of this application, execution of this application, and what are the requirement each and every application had, the operating system will suffice the need. So that is all the role of the operating system, guys. So operating system will, it is nothing but it is a system software, right? That's what we have written. It's a system software, or it's a set of programs or modules. So what is operating system? Operating system is nothing but it's a set of programs, or it's a set of modules actually. So OS is nothing but is a set of modules or program, right? So it means that this the entire operating system, it is written in some code. Okay, so what is that code? Basically, always operating system is written. Most of the operating systems are written in C language. Okay, but yeah, there are some operating systems which are written in different language. We'll discuss all those things later. Yes, now they are written in a C language. So to code the whole operating system, right? They have used some kind of a model concept. So using a model concept, they have developed a lot of models, and they have integrated each and every model, and together the models, they call it as an operating system. Okay, now each and every application, whenever it want to interact with hardware, it want to communicate with the hardware, with the operating system. Without the operating system, the application cannot run, or it cannot communicate with the hardware. So the definition about the operating system is nothing but, now you can say operating system is the word. One more definition: operating system is an interface between the application and the hardware. It's an intermediate, or it's an interface between the application and hardware, right? Without operating system, I'll say in a shortcut OS, without operating system, the application cannot interact with the hardware. Okay, there has to be an operating system, right? Now, okay. So now, as I said, like operating system is nothing but it's a set of program or a set of models that controls and coordinate hardware resources for the different application program. Correct. Now, okay, fine. That's what we understood. But now the question comes, okay, fine. I understood what is an operating system, but what is operating system is made up of? Okay, we already said that operating system is nothing but set of models. Oh, there are models are there. What are those models, or what are the subsystem of the operating system? Subsystem of the operating system. Guys, each and every operating system, it has all the subsystems. There are basically 5 subsystems are there. What are those five subsystems? Process management, memory management, file management, network management, and finally device management. Means your operating system is made up of all these five subsystem of the operating system. Okay, guys. So now, so like if somebody asks you what is an operating system, yeah, you say it's an interface between the application and the hardware, correct? Between the application and the hardware, right? So without operating system, the application cannot interact. So here you could see that without the application cannot interact. Fine. It's all okay. But okay, I need to learn or I need to understand what are how exactly the operating system is made up of, right? So operating system is made up of these five subsystem base. If you go and ask in Windows operating system what our Windows operating system is made up of, it is made up of these five subsystem. If you go to the Mac OS and you ask them, okay, what internet it has this five system. This is kind of a common which each and every operating system has. Okay, Linux or Unix also has the same subsystem: process management, file management, memory, network, and device management. So now, if you ask me, like now, if you tell that Rajesh, do you have to learn all these things in detail? Not required actually. You need not to learn all these things in detail, but you should have some basic understanding about all these things. What are these things? So, shall we learn what exactly each and every subsystem does? Later, we will see. Whenever we required to learn about this subsystem, right? I will go in detail. But as of now, you have to only learn one line definition about each and every subsystem. So, what it does basically this. So, I'll just in the process management, I'll just say PM. Okay, process management is one of the important subsystem of the operating system, yeah, which take care of creating the process, termination of the process, okay, scheduling the process, as well doing or performing inter-process communication. So what is this inter-process communication and all? You need not to worry, right? Now what this process subsystem manage or the process management does, it says that it is the important subsystem of the operating system which take care of creating the process, terminating the process, scheduling of the process, as well as performing the inter-process communication. It means that these are all the roles and responsibility where the process management does, right? So now, so if you ask Rajesh, okay, this operating system has all the five subsystem, what I was saying: process management, okay, memory management, okay, file management, okay, device management, okay, and network management, right? These are the five subsystems you say. But one among is a process management that will take care of the creation of the processes. This is what is a process? Okay, what is a process? Now the question comes here. What is a process? I'm asking you in an operating system concept, guys. What is a process? So process is something like we say in the industry also, right? We are following some process. Okay, there is some rules and regulations are there. Some rule is there, right? So we need to follow that rule. So if you follow that rule, it means that we are abiding to a certain process, right? Yes, that is a terminology we use, process. But I'm asking you, what is a process, or what is a process when it comes to the operating system or the system level? Like, what is a process, guys? Anyone has any information on what is a process, how you define a process, something like anything, like for example, yeah, what is a process, how you define a process? Of course, this
Process
is
is
one of yeah,
Rajesh, process is nothing but sequence of steps or sequence of operations.
sequence of steps or sequence of operation, correct? Sequence of steps or sequence of operation, something, okay, okay, correct. That is what called process, right? Correct. Now, that's correct, sir. Now, some people say that process is nothing but it is something, it is a running program. Correct? It's like a running program, right? So you say that whenever any program is running, it is executing or it is running because of the process, actually, right? Now, that's correct. Okay. Now, how you can define a process in a very nice way? Process is nothing but It is it's a process, nothing but it is a program, or process nothing but it is a running program, or running program, sorry, running program. Now whenever any application it want to get executed, suppose here if I click or double click on the Google Chrome, see, you are running an application. Correct. You are running an application, but how exactly this application will get executed? This application, that is a browser, it will get executed with the help of a process. Actually. So now what happened? If you come back to here, you are running an application. Okay, running a Chrome browser. So when you do a double click on this Chrome browser, it is actually executing that Chrome browser. It means that you are actually launching a Chrome browser. But how exactly this Chrome browser will get executed? It will get executed with the help of a process. Like this. A process will get created. So this is nothing but it's a process space. So what you say that a process in what it is a running program. It is a running program or program in execution. We call it as a process. So whenever you want to run any application or whenever you want to execute any kind of a program, the program will get executed with the help of a process. Without a process, the program cannot get executed. Later, we will see that how this process are getting created. Just I'm saying that whenever any application, it has to get executed, it can execute it with the help of a process. Without a process, none of the application will get executed, right? Now, who creates this process, right? Within the operating system, there's a process management model. That process management model will create a processor. Okay, whenever any application has to get executed, okay, operating system within that you have process management that will make sure that it will create a processor. Now, what happened? If you see each and every processor, whenever any process is running or whenever any process created, you know that each and every process will have some kind of a subsystem within it. Actually, some of you might have known it, or some of you might have read it. Like it has a text segment, it has a data segment, it has a stack segment, it has a heap segment, it has some kind of a environment variables, it has some kind of a pending signals. What is it? You know to break it right now. Pending signals, signals, signals. Each and every process holds all this information. It has a text segment, data segment, stack segment, heap segment, environment, and pending signals. So whenever any process is getting created by the process management model of the operating system, every process will have all this information: text segment, data, stack, heap, n1 variable, pending signal. There are many other resources are there. I'm just telling you, sir. These are all some kind of resources where each and every process possesses. So it means that whenever any application has to get run, first the process management model has to create a process, and it has to fill all this information. Who will fill all this information of each and every process? The process management model only will get will create all these resources inside the process. Okay, now all these resources are filled. Now what happened, right? Oh, you allow this process to run. So the process management will allow this process to run. How will it allow the process to run? Means, oh, your process management model has to assign some kind of a CPU. It has to assign some kind of a CPU cycles, right? Some CPU time slice has to be assigned, right? CPU time slice. Okay. Okay. Then it has to make sure that, oh, please run this. So to make sure that what the process management model will do, it will talk to their scheduler. Hey, you make sure that you try make this process to run, man. Okay, talk to scheduler. Scheduler, what happened based on the time slice, it will make the process to run. Okay, and of course, each and every process it requires some memory also. So who will give the memory for each and every process? The memory management model or the memory management. This is one of the subsystem. Assume that this is the memory management and this is the process management. So the process management model, it will communicate to the memory management model saying, hey, please give me some memory, man. Okay, it understand. Okay, based on the application requirement, your memory management module will assign some kind of a memory for this process. So you could see that all these modules of your operating system, it is not like they're a single entity. They are they have a intercommunication also between one module and other module. That's all there within the operating system. But once this process is running, once it has provided a CPU time slice, when the scheduler schedule this process, the process is running. It means that your application is running. Once it completes a task, this process has to get terminated. This process to be killed. Who will kill the process again? The same, process management only. See here, as I said, process management model, it will take care of creation of the processes, termination of the process, scheduling the process, as well as performing the inter-process communication. So it will create the process, it will allow it to run the process, and finally, when it completes the task, it means that you have completed the execution of the program. It means that the process has completed the execution of the program. Then what happened? The process to be killed. Who will kill? The process management only will kill. So everything when it comes to the processes, the process management module of your operating system will take care. Okay, guys. Now, what is the inter-process communication? Inter-process communication, you say, Rajesh, okay, fine, Rajesh. If suppose there are two processes are there, I'm just saying that. Don't worry about all these things. We'll come little in detail after some time. Just say that, okay, there's a process A and there's a process B. So this process is there. Like the process name is A and this process name is B. You say that, Rajesh, both this process want to do inter-process. They want to communicate to each other. Okay, there's some requirement that he has to communicate each other. They can communicate each other with the help of some kind of IPC tools, inter-process communication tools. Inter-process communication. IPC means inter-process communication tools. Like for example, you have pipes, we have FIFOs, we have something like a message queues, shared memory, semaphores, of course sockets. See, these are all the different IPC techniques: pipes, FIFOs, message shared memory, semaphore, message queues, as well as your sockets. See, these are all the inter-process communication techniques which is used. These are the kind of a tool or which is used within your while communicating with two different processes. You use this techniques. So this we call the IPC. Even these are also a part of your process management. So in your inter-process communication, you will get all those things: pipes, FIFOs, message queues, right? Shared memory, sockets. See, it all comes under process management model. Correct, guys? Guys, are you clear till here? I know that for some of you, it might look very weird. What is this, man? What Rajesh is trying to tell us? He's telling something different things. But yes, you just follow me as I'm telling now. As of now. Don't worry. Many things are there which will be clear after some point of time. Don't worry now. Okay. So we are learning about what is a different subsystem, right? So inter-process communication. Fine. No, that's all. So this is one line definition. That's what you need to know. One line definition. Somebody asks you, guys, what is a process management node? You have to tell this. It's an important subsystem of the operating system which take care of creating process, termination of the process, blah blah blah. You have to tell all these things. That's all, guys. No other thing. If you ask me what is it is it's a very big subsystem of the operating system where like a lot of things are done. It is just I'm just giving you one line of information, guys. That's all, right? Okay. Some of you might have come across with this. I'm not sure. I'm just guessing. Shared memory. I don't know. So how many of you come across this? But I expect that some of you might have come across shared memory somewhere. While working it, you might have come across shared memory and all. So just think about it. If you have come across it, yes, you would know that what I'm trying to tell. Okay. Pipes. Obviously, we have come across with a lot of times. Pipes. Obviously, every day, right? Some of you might be executing this command. Like ls-l pipe it to grep something, some word, right? Some kind of a word, right? You are using this pipe symbol like this. This pipe symbol is not for this one. This pipe symbol is not for this pipe actually. Okay. So okay, fine, that's fine. Now Now, coming back to here, guys, what is the next one? Next is what is memory management. Of course, what is a memory management model? Okay, the memory management model, it is also one of the subsystem of the kernel. Oh, sorry, subsystem. Yeah, I have used the word kernel now, but I will come up later. What is a kernel? But I'm just telling you about the operating system. Okay, each and every operating system has this 5 subsystem, right? So the memory management model, the memory management, I'll say MM. Okay, subsystem of the operating system will take care of allocating the memory, deallocating the memory, okay, deallocating the memory, okay, and transformation of the data from primary memory to the secondary memory, as well as vice versa. Means vice versa also. That means that vice versa means transferring the data from the primary memory to the secondary memory. Again, from secondary memory to back to the primary, everything is taken care by the memory management. Okay, so memory management, like as I said earlier, like whenever any process would start getting running or it's get created, it needs some kind of memory. So the memory management model of your operating system, it allocates some memory to it. Okay, take some memory, take some 5 10 kilobytes or some few memories, take and start getting executed. Whenever this process completes its task, it has to give back that memory, or it has to free that memory, right? So that's what the memory management model will do, right? After that, what else it does? It does something like a transformation of the data from the primary memory. What is primary memory, guys? Primary memory. What is primary memory? Primary memory is nothing but your RAM memory. This is your RAM. And of course, I know that most of you know what is a RAM memory. It's a primary memory. Primary. Okay. What is the secondary memory? Secondary memory is nothing but your hard disk. You have a hard disk, correct? Your hard disk. So whenever you want to transfer the data, there are some transfer the data from your primary memory to your secondary memory. And again, whenever you want to read the data from your secondary memory to a primary memory here, you need a memory management. The memory management is required. Management is required. See, now what is an example? Suppose you say that Rajesh, I have a file, something like I have an Alice file. I have saved this Alice file in my hard disk, and there is some content also, right? Tomorrow morning you come and you boot up your system, the operating system will come up, and you log into the system. Suppose you want to open this file, what you're doing, you are either doing a VI command, I'm talking Linux, or else you are using cat command to open that file, right? So basically you are trying to read a file from your hard disk, right? So whenever you read the file, whatever the content of the file which is in the hard disk, that has to be first fed into your RAM memory. From the RAM memory only, when the data comes to RAM memory, then the user can read it. So it means that you are actually transferring the data from your hard disk to the RAM, right? Suppose you say that Rajesh, I am creating one file, Bob file. I'm creating a Bob file. You are doing a touch command to create a Bob file. Okay, most of you already know this. So you are creating a file, Bob file. So here in the RAM memory, you're sitting and you're creating a file, touch Bob. So doesn't that Bob will get created into your hard disk, guys? It has to get created, right? So some kind of data transmission should happen from your primary memory to the secondary memory, right? So this transformation of the data also been taken care by the memory management. So memory management of your operating system, it takes care of creation, allocating the memory, deallocating the memory, transformation of the data from your primary memory to secondary memory, again from the secondary memory back to the primary. Everything is taken care by the memory management. Some of you might come across with some terminology, like for example, segmentation. Some people might have come across with something like a paging, right? So these are also a part of your memory management. Okay. Apart from this, guys, Some of you might have come across with some terminologies like logical address, virtual address, or virtual memory, right? Somebody might have come across with some terminologies when you're working. A physical address, they'll say. So you might ask, what is this, guys? What is this logical memory, physical memory? Are these are related to the memory management? Yes, they all are related to memory management. Physical memory, you say that it refers to some kind of an address. Correct. So whenever, guys, whenever you're working on a RAM, when you're working on RAM, always each and every RAM memory, it has something known as a concept like a pages. Actually, we will little bit will go in detail after some time. I'm just telling you for your knowledge now. It is something like a page actually. This page is done, but it's a physical address, guys. Just understand that. That's all. Okay. So, so that's how you have to understand. Okay. So now, whenever you come with the kind of a some terminology like addresses, and everything, right? You can very well understand. Oh, it's a part of the memory management only. Nothing apart from that. That's what you have to understand. Okay. So now we are just learning one line information, guys. Nothing to worry. Okay. I know that some of you have a lot of doubts, or some of you already have some knowledge, but we'll slowly one by one we will clarify all these things in our upcoming classes. There are many concepts are there, many commands are there related to this memory management. There are many commands are there, many concepts are there related to process management that we will be dealing in each and every session whenever we in the upcoming sessions. So slowly one by one it will get cleared. Not to worry as of now. Okay. Now file management. You know that very well that what the file management system does. It will take care of creation of the file, creation of the file, deletion of the file, deletion of the file, maintaining the files in a proper like hierarchical order, hierarchical manner, hierarchical organization we can say, right? So guys, actually we will pause this video for some time, or else we will just because the BBMP van has come, so unless it will disturb our class, right? I will just pause for 5 minutes. Let this goes van goes. So guys, what I've written is that actually here, see, file system is done, but it is one of the subsystem of your operating system. It will take care of the files. It means that you want to create a file, you want to delete a file, you want to provide some kind of a permission to the file, and everything it will be taken care by the file system file system model or file management actually. Okay, and maintaining the file in a proper hierarchical order. See, each and every file management or each and every file system, it knows that how I have to create maintain a file system structure, right? There is some kind of a structure there where it maintains it actually, right? So that's what, like you have a fat Windows. If we come to Windows, right, we have file systems like fat, vfat, interface. It understands how to make place or how to keep all those files or directories or folders into some proper order or into some hierarchical order. That's what Windows understands. Similarly, Linux also has some file system like ext3, ext4, Razor file system, XFS file system, like that you have. So it also understands basically what happened. File system will take care of the formatting of the disk also, or creation of the file system. Suppose you have a new disk or new disk partition which has come. So now you say that, Rajesh, I want to format this disk, or I want to format is not what you want to afresh create a new file system onto the disk actually. So that also the file management will take care of it. So the file management will take care of all these different file system, guys. Like for example, we have a Windows. Under the Windows category, we have a under for the Windows family, we have FAT, VFAT, NTFS, right? Under Linux operating system, you have ext3, ext4, Razor FS, right? And the CD-ROM, like you put a insert a CD-ROM, right? The CD-ROM has an ISO 9660 CD-ROM file system. And there are some other file system, different file systems are there. HPFS, hierarchical priority file system. Okay. HFS, hierarchical file system. Like we have a network file systems. Like for example, you have NFS file system is there. Android file system, Coda file system is there, right? Or else, for example, even like there are some special file system also there. For example, you have a proc file system, right? Proc file system. It's a special file system, right? Sys file system. It's a special file system. So this and all will come into it later after a point of time. But so the whole file system stuff is been taken care by your file system model. Okay. Now, what about the next stuff? Networking. Guys, I hope that you guys are understanding whatever I'm saying. Right? I hope you are understanding. Now, network management. Network management is also one of the subsystems of the operating system, right? So what the network management model will take care of? Network management model will take care of your transmission of the packets actually. Transmission of the network packets, we say packets from one machine to another machine, right? One machine to another machine, right? So that how it happens. Like here you have an example. Suppose you have an example of two machines. If there are two Linux machines, or if there are two machines which are having different operating system or the same operating system, if these two machines it want to communicate each other, if they want to communicate each other over the network, right? They need a network management model in their operating system. If the network management model is not there in their operating system, so then these two machines it cannot communicate each other. There has to be a network management model. Okay, so network management model will take care of connection between two machines because you want to connect each other. Okay, you want to connect each other. So okay, to connect each other, basically you need some kind of a socket file here, or you need some kind of a socket here. So if you have a socket here, and if you have a socket here, then only these two machines can communicate each other. So this is nothing but it is a kind of a, this we call it as a socket. Socket. So without a socket, two machines it cannot communicate each other over the network. There has to be a socket. Of course, there are some protocols are there, or right. We need to use either TCP protocol or UDP protocol, right? We have come across with a lot of these terminologies, TCP protocol, UDP protocols, right? So they need some kind of a protocol, right? As well as they need some kind of a uh, some kind of different application like to communicate each other. So either these two machines they can communicate with the SSH, or either they can communicate with an FTP, or either they can communicate with a telnet, right? Right? These are the different ways where the two machines can communicate each other. So all this communication between two different machines, transmission of the network packet from one machine to other machine, right? Everything is taken care by your network management model of your operating system, right? Device management. Device management is basically something like, suppose if you are having so many devices here, you are having so many network devices, sorry, so many hardware devices, like you have a keyboard, you have RAM, mouse, and everything, right? Your operating system, it want to communicate with each and every hardware. So how the operating system can communicate with each and every hardware? With the help of a device driver. With the help of a device driver. With the help of a device driver model, it will communicate. So this device management is number, it contains all the device drivers to communicate with all the hardware. So basically what happened, right? This device driver model, it's contain all the device driver hardware. What is device driver hardware, sir? It is like a software actually. Okay. Now, for example, to make it explain, understand that. So here an application is running. This application is running. Here you have an operating system. Sorry, you have an operating system. Operating system is running, and here you have a hardware. Here the below you have a hardware. Correct. Now you say that, Rajesh, my application, it want to interact with one of the hardware in the system. Okay, what is that hardware means? Basically, the hardware is, but this hardware is not, but it is a parallel port actually. Simple. It's a same parallel port. Parallel port or serial port, right? Something. Okay, and you see that the same application, guys, it want to communicate with my network card actually. This is my network card. This is my network card. So basically, my application, it want to communicate with this hardware actually. How it can communicate means basically, in an operating system, you have something like device management, right? That is one of the subsystem of the model, right? Within the device management, it has the parallel port driver, as well as it has the network driver. Network driver. Okay. Now what happened? This application, it communicates the operating system saying that, hey, I want to communicate the parallel port driver. Okay. Now the operating system, what it will do, it will try to communicate with the device management. Within a device management, there is something like parallel port driver is there. Okay. It will try to call this parallel port driver. Okay, this parallel port driver will finally will communicate with your parallel port driver, and this parallel port driver will finally communicate with the parallel port device. Similarly, your application want to communicate with the network card, right? This will be something like it will be something like a Realtek card, right? You have a lot of different network cards are there, right? So what the application will do, the same stuff. The application will try to communicate with your network driver, with your operating system first. From the operating system, the communication goes to the device management. From the device management, what happened, right? The communication goes to network driver, and from the network driver, the communication goes to the network card. Like this, the communication happens. So your device management, it contains all kind of a drivers where those drivers can communicate with the end hardware. So the device will contain all the interpreter drivers to communicate with all the hardware. So there are so many different devices are there, sir, with us, right? We have a lot of different devices, like we have a mouse, we have a keyboard, you have a screen or terminal, you have a lot of, you have a USB port, right? You have a parallel port, you have a serial port, you have a network card, right? you have an audio driver, you have an audio device inside, you have a video device, like you have a graphical card also, right? So each and every hardware are there. How this hardware can be communicated by the application or by the operating system with the help of a device driver itself. Without a device driver, the application cannot communicate with this end hardware. And all these hardware devices, they are actually divided to, broadly they are categorized to three categories. One is a character driver, four actually character devices. Under that, you will get something like a parallel port, serial port. Yeah. Who uses this parallel port, serial port? The keyboard device will use the serial parallel port. Like that. Next is a block devices. What are those block devices? Guys, you have a hard disk, you have a CD-ROM. Earlier we used to even have floppies, right? Floppy. All these were using block devices. Third is a network devices. Of course, or your network card. For example, the network card example is nothing but Realtek. You might have heard about Realtek network cards. There are many other vendors are there, a lot of different manufacturers device. One example is Realtek network card, right? And the fourth is a miscellaneous driver. Miscellaneous driver or miscellaneous device. Like for example, your USB, right? Your USB, it falls under the miscellaneous. Your mouse driver, your mouse device it falls under the miscellaneous category like this. So you have a network device management, and it has broadly four categories of devices comes under this. Okay, guys. So are you okay till here? So these are we just described in one line information about each and every subsystem of your operating system. Guys, are you okay till here? You have any doubts? Till here, are you okay?
Yes, Rajesh.
Okay, good. Thank you. Now, so see, guys, what we will do, we will have each and every session of 1.5 hours. We will not exceed more than 1.5 hours, right? Because we have to take a lot of sessions. So we will bound to fix for 1.5 hours itself. So I will take another 15 minutes more to complete the task or to complete today's session. Okay. So now, this basically this operating system, they call it as a kernel. Call it as a kernel, right? So your whole operating system, guys, this complete operating system, what we are calling this, we call it as a kernel now. Actually, we call this as a kernel. If you say kernel or the operating system, it's one and the same. There's no difference actually. But still, people people in the Linux world or people in the Unix world, still they call it as a kernel. They don't call it as an operating system because so that's how the word key came, kernel. So kernel is a main core of your operating system, or we call it the main heart of the operating system. So the kernel is the main core of the operating system, or main heart of the operating system. 95% of the job of the operating system is done by the kernel itself. Or you can say kernel is a non-detachable part of the operating system. Okay, now when it comes to an operating system, right? When it comes to operating system, what we say that actually that I'll draw it here actually because I won't open more. I will not open more MS Paints. This is an operating system. Okay, guys, this is an operating system we call. This we call an OS, right? But within the OS, the 95% part of the OS, the 95% of the part of the OS. This is the 95%. This 95% part of the OS. 95% of the OS is nothing but it is a kernel only. Please try to understand. So if I say kernel or the operating system is one and the same, nothing. And this kernel has all the subsystem, network management, file model. So your kernel is made up of all those five subsystems. Process management model, network management model, like this PM, process management model, memory management model, file management, network management, as well as the device management. These five subsystems are nothing but it's a part of the kernel only. Now you could say that what is this 95% of the operating system? Why not 100%? You say why not 100% of the OS will be called as a kernel? No, we don't call 100% of the OS as a kernel because like you have some 5% of your operating system. 95% okay. The 5% of the operating system is written in the assembly language. It's 5% of the operating system. It is written in the assembly language, sir. Right? So it means that basically you need to have some kind of an assembly language code with which actually what happens, the kernel will communicate with your devices. And this 5% of the operating system, which is the assembly language level language, this we call it as a HAL. Call this as a HAL. Call this as a HAL. HAL means hardware abstraction layer. Hardware abstraction layer. See, now to give an analogy, guys, like for example, right? For example, if you say that, Rajesh, I want to eat puliyogre, right? Right? There is a puliyogre which is a very famous dish in South India, right? In North India, you won't get puliyogre and all. But people love to eat puliyogre here. Now, if you say that, Rajesh, how to prepare a puliyogre, it's very simple, right? You have to cook boiled rice. And what you have to go that you have to go to the shop. You need to get a puliyogre mix, right? Like for example, you can go and get the MTR puliyogre packet or else some other puliyogre packet. You can get it, right? Everest puliyogre packet, cup home there. And what you have to do, you have to just put that puliyogre packet into the boiled rice and just to stir it. And it's nicely mixed, right? And now when you try to give the puliyogre to you, if you eat it, you'll say, Mom, there is some salt missing. Is there? Salt is not added while preparing food. So what your mother will do, she'll put some pinch of salt and she'll mix it, right? So that your food becomes a palatable food. It becomes a eatable food, right? So if you don't put any salt, your food is a non-palatable. It is non-tasty. You won't get that kind of a taste, right? So obviously you have to put some kind of a salt. So that salt is nothing but your assembly level language instruction, or nothing but is HL. Your whole puliyogre is nothing but your 95% of the operating system is puliyogre only. It's a kernel. So that 5% inch pinch of that salt is nothing but is your HL. It is nothing but it's a HL. Now coming back to here, now uh, now what to say that, Rajesh, my application want to communicate with the network driver. Okay, fine. How it communicates? The application will communicate with the operating system. The operating system will communicate with the device management. The device management will communicate in turn with the network driver. The network driver will communicate with your hardware abstraction layer, with your HAL. This hardware abstraction layer, from the network driver, it communicates with the hardware abstraction layer, and this hardware abstraction layer will communicate with the network driver. So now we would say that, Rajesh, doesn't this device driver code, doesn't it directly interact with the hardware? If you ask me, no, sir, it always interact with the HL, sir. Hardware abstraction layer. From that hardware abstraction layer only, that will finally communicate with each and every device. Is it clear, sir? Are you okay? Have you understood what I said? So hardware abstraction layer should be there. And in which language it is written? Sir, it is written in the assembly level language, because if your machine is an x86 processor, and then it is not but it's an x86 assembly language instruction. So it is not but it is a x86 assembly language instruction. Sorry, my spelling is going wrong. LANGUAG language instruction. That is. So this 5% of operating system which is nothing but HAL. This is basically written in the assembly level language. Okay, fine. But what is the kernel or the operating system is written 95%? Oh, sir, it is written in the C language. Sir. This is written in the hard C language. It is used. You know, guys, have you heard about Windows 95? Windows 95, the great, the first Windows operating system was released by the Microsoft. Right? Windows 95, very people started using like anything. The whole Windows operating system 95 is written in the C language only, sir. Even Windows 98 also is written in C language only. C language only. Later, what happened, right? Windows NT, Windows Vista, Windows XP, Windows 10, all are written later. They have written in a different language. So Microsoft, what they did, right? They had developed their own language, and they started writing the operating system code in that language, sir. It means that they stopped using the C language and they use their own language. They develop it to code the operating system itself. But today, even till today, even any kind of a Linux version or Unix version is coming into the picture, they are still using the C language itself to code it actually. So the whole source code of your kernel of the operating system is written in the C language. Okay. So okay guys, there are many things are there which I am planning to cover now, but because since we are going out of time, right, so I would stop it here itself. So we will continue again at around what's the time, sir? We'll continue again with the 10:30, right? We'll give a break of 2 hours and we will continue with our next session. Clear guys? Because now the things will get interesting. A lot of things are will come into the picture now, where you'll be learning about the Linux operating system itself. Now, what is Linux operating system, how it works, what is user space and kernel space. Very interesting. You will learn a lot now. So this was just a basic stuff actually, because we have not yet covered still. This is still there are so many basics that which I have to cover now to complete this thing. But we just try to understand what is the operating system, okay, and what are the different subsystems. And now that operating system, now finally we call this as a kernel now, right? And the whole operating system is not, it's not only complete operating system we call the kernel. 95%, almost most of the code, 95% is a kernel itself. Only 5% is nothing but your HL, hardware abstraction there. Both together, kernel and this 5%, everything together, we call it as a operating system. Or we can even, in short, we can even call it as a kernel only. And kernel is a main core of your operating system or main heart. So from now onwards, I will not tell as an operating system. I will always say as a kernel. Okay, guys. I will not use the word operating system. Kernel, I will say. Kernel is not, but it is an operating system itself. Okay. Okay, guys. So then, if you have any doubts, let me know, or else we will stop the session. Today's session. Okay.
Okay.
Okay. Okay. Somebody can stop the sessions. I think if